Everybody, I greet you now. I greet man, I greet woman, I greet everybody. Thank God for another day like this. Now maybe John Ogunje, my brother, my friend, and they represent Gigatech Venture. This platform, this series of lectures where we do show, now to sensitize people, teach people, tell them about solar electricity. If not, you know the person say you want learn but you don't see where to learn, or there are some certain things where you don't understand. Now here be the platform where you go ask your question, where you go know all those things. So well, last week now we start. Last week we come teach us about what it be solar electricity. We come tell us about the different kinds of solar panel. We particularly emphasize on solar panel. Talk about the different types of solar panel. We can carry one where they call monocrystalline. Come teach you now all the different parts where they talk about the parameters and the characteristics where they, because you do some tests. So if you never watch that video, don't miss them. I suggest say go watch that video before you come watch this new one. And if you never subscribe, you know go fit dey get our video. So you need to press that subscribe button. Go to the bell icon, press am, so that anytime we produce videos like this, that you will be the first. We get another topic, very very important, very very vital. That topic we call them solar electricity. Many of us go, yes, wetin be electricity, electricity, electricity. Electricity, if you want bring am down, it means the flow of current or the movement of current from one place to another. That is the meaning of electricity. Current no go fit just dey move by itself. There are some other things wey they call quantities, wey e dey, wey dey make current dey move from one place to the other. So now today we want to look at all those things. And what be those things? Number one, that be voltage. We go look at what be voltage. Number two, that be current. What be current? Do they hear say current? What it mean? Number three, we will still discuss power, electrical power. What be energy? So now those things we want to put together today. Explain as small as all of us go fit get them. Stand by. Current. What be current? If we go to Ikpoba River now, if you stand for the bridge, you go see, especially for the center, you go see the way the water they roll. But by the edge, the boundary, you go see those ones go the rock cool. So basically, say current dey this center. What it mean? It means that the volume of water where they pass at that particular point per second is high. So that's what it still be for electricity. Current they flow through wire. Although we know they see am for eye, it dey flow through wire. And as it flow through wire, now wetin they call electrons, now be the current. They are in trillions. Many small negative charge particles, electrical particles, now be electrons. So whenever there is electricity or flow of current, it is the flow of this electron where they move from one point to another. For instance, now look at this simple setup. Now, just look at. See the solar panel. Now this solar panel, it dey generate current. Now DC current. DC current means say current where they go only one direction. You know they go to and fro. Now one direction, you go they move. Come see what you dey talk. See the current now. See or let's say 5 amps. Now they come on so through this place. Because current come out. See go enter the battery. See it dey store, as wetin dey happen now, it dey store that electron for here. That electrons wey carry energy, it dey store am for here now. So these are DC current. Also look at this fan. As this make I can show you example wetin panel, solar panel fit do. See inverter no dey now. See this one na DC fan. So it dey work direct from the sun. As the sun dey meet the panel, it produce a direct current where they enter that place. So as this one is going, so as this one is working, electrons are flowing through this circuit. So that is what is called electricity. You understand? That is electricity. The flow. Now two type of current now they see. But the one we dey talk about today now be direct current, DC, direct current. That one now we dey take particular about. Alternating current na current wey dey go up and down, go here, go here. When they hear of current or this electron na something wey no get joy. Electron no know anybody. So that is why if you see wire, make I show you an example. Now you go see am, they cut am. Now this naked part, now the electron dey flow. Because the thing dey vex, if it dey move, it not get joy. If your hand by mistake touch am, that person don collect. So that's why they can't use this insulator wey not dey allow electron pass, take cut am for protection. So if you dey work with line like something like this, make sure you wear bata, wear thick shoe. This type of meter they measure current. The unit of current now that they call ampere. If you want to know say how many, what will be the amount of the current where they flow, say now 5 amps so now 6 amps so, according to the way that case go be. So the unit of current is amps, and the mixed instrument where they take the measure now that they call ammeter. So this is my DC ammeter. I will just set am here. Now see I go set am here, put am, take clamp the wire. You go see this, will tell me the amount of current where they flow through that particular point. For instance, here now, see 5 amps, 2.5 amps, because the value they go up and down, 2.5 amps. So now be this work. So if I want to know the current, now just to clamp am to 1.06. Now be the current where they enter this fan, so where they make the fan they work. So that is about DC current. Said again, current now the flow of electrons, and these electrons are negative charge particles that flow during the process of during electricity, the movement, charge particles. And also the unit is called ampere, and the instrument where they take the measurement now they call ammeter. That quantity where we go see look at that they call voltage. They hear voltage. What it be voltage? Voltage, for instance, like as you dey fetch water for tap, if you open am, you go see say the water dey rush come out. Wetin dey make that water rush? Na the pressure wey dey inside the tank, the level of water wey dey, na dey determine the rate wey the water take dey rush come out. Na the pressure dey push the water come dey come out from the tap. Na so electricity still be, and the simplest way we go fit explain am. The thing with that current wey I dey talk since, the thing wey dey make the current dey wakara. When I say wakaring, or flow of current or flow of electrons, wetin dey make am flow, wetin dey give am the energy to flow, na be voltage. So it is voltage that makes electric current to flow from one point to the other point where they want use am. For instance, see wetin we get for here. See this battery now. This battery don't charge. The voltage na so it don't charge. You understand? So now this voltage, now they pump the electrons where they flow through this wire to that fan. Now the same voltage as we take connect this inverter, so see the breaker. See this inverter they on now. Now they feed this voltage. Now they pump whether na DC current or whether na AC current or now they pump the current to the flow from one place to the other. Like here now, see this one now, this battery now. We don't store energy here. Many trillions or countable electrons now dey here now, charge particles. So as we connect this inverter on this inverter now go change from DC to alternating current AC. Now we take power this keyboard now. See from here. See now AC enter there, AC current. But here now, this one are directly from the panel, the solar. See am, because this fan na DC fan. So now the voltage they make current they push. The higher the voltage, the more the current go sit a push. So voltage still get unit. The unit of 1 volt of voltage or volts is called volts. Now talk am again. The unit for voltage is called volts. Go see am for up there where I write am. The unit for voltage is called volts. And wetin we take dey measure am na they call voltmeter. Although it's a multimeter, it can still measure current, but I wan use am voltmeter. See where I put am for this range. Come make we measure our battery. Red to red, black to black. Now see am, it dey give us what? 40.2 volts. 40.2 volts. So now this 40.2 volts, now the electrical force, or call am electrical pressure, where they make this current they move. And as the current they move, they carry energy, they follow body. Anything when you put for their road, where you meet, not to fight am, not to collect. You know, say as we put this one now, this one don't collect. Now they make the road so. So it's converting electrical energy to mechanical energy. Like if you see on your generator, when you go plug am, the electric current go flow, enter inside your house. Many things go just dey on. Now the electrons they do am. As they flow inside your bulb go light. As they flow inside your fridge go dey work. So now voltage, now they make current dey flow. I hope you understand that. What we want to consider now be power. Wetin be power? Power na the amount of energy that a system produce or consume by unit time. For instance, if I on my borehole for my house, for my system, and I constantly on like let's say refrigerator, that borehole now go draw more current, now go draw more energy by second than the fridge. So in such a case, you go see say now the borehole now get power pass. Why it get power pass? Because it dey draw more energy by seconds. That's why I fit stay explain that. It not be like a mechanical power. Person wey feel dey lift something fast, but this one is electrical power. So now the rate of consumption or production of energy by unit. Power also power get in unit. The unit of power now be watts. You go say my television na 120 watts. My solar panel na 100 watts. So with the talk of the power, anytime you hear say they say watts, na power. And also it still get a mathematical relation where the fit relate current, voltage and power together. Power is equal to current times voltage. Now be the mathematical relation how they relate, they marry. Power is equal to current times voltage. Power is equal to current times voltage. That be the last thing we want learn today. That be energy. What be energy? We don't talk about current, voltage, and power. Energy. For instance, if you get say 100 watts load, you connect them for 1 hour. The energy there is 100 watts hour. Energy is measured in watts hour. Look at this battery now. See, this battery is 12 volts. See, 12 volts, and it is rated 100 amps hour. So to get the watts per hour of this battery is 12 times 100 amps hour will give you 120 watts hour. So if you want to be installer, maybe they call you, say, okay, come check my house, so maybe you come size everything we do, so that we will know weighting that they use for that house, so that you will know the amount of batteries, you know the amount of panel where they want to put. Now this watts hour, now they take the do them. So you must be very, very familiar with watts hour, because it will make your calculation very, very, very easy. or like this one now, you fit calculate and know the time wey go take for this battery to get charged. You go fit calculate, still know the time wey this battery go discharge. So watt hour is very very important. So I hope say una understand. So na the best way I fit tell una. But if you get anything wey you no understand, wey never see clear, please just make your comment for the space below. Then we go find way we go take respond to you. So if you never subscribe, please press the subscribe. All the other video wey go see dey follow this, you go see dey see am. I thank una very much.